All right, so we talk about application layer. Now we are moving on to transport layer, and we are still using the slides from this book, Computer Networking: A Top-Down Approach by Jim Kurose and Keith Ross. Of course, I removed a lot of slides, so because we are not interested in on the network. This is the network security course, so we are focusing on the parts which we need when we talk about security. So let's look at the overview of this layer. Our goals are as follows: understand principles behind transport layer services. Here we will be talking about multiplexing, demultiplexing, reliable data transfer, flow control, congestion control. Of course, here there are more to talk about. I will not go into detail. I will just explain how we can do this reliable data transfer. More importantly, we will talk about Internet Transport Layer protocols, UDP and TCP. Okay, because then we will talk about actually what the attacker can do when we talk about security. So we need how UDP and TCP works. Yeah, the roadmap of the book is as follows: transport layer services, multiplexing, demultiplexing, connectionless transport UDP, principles of reliable data transfer, connection-oriented transport TCP, principles of congestion control, TCP congestion control, and evaluation of transport layer functionality. Here we will talk about actually HTTP3, where we actually going to try to provide security for UDP and have faster communication and so on. So last part is actually something new, because as far as I know, it is not finalized. The RFC is still in draft mode. Actually, it was in draft mode in 2020. Maybe it is finalized, I don't know. But Google uses it anyway. So we will talk about quick protocol, which would replace, kind of UDP and TCP if everything works out well. All right, so let's focus on transport services and protocols. So they provide logical communication between application processes running on different hosts, right? So let's look at the picture. In the previous part, we talked about application layer. Here we are talking about transport layer, where logical end-to-end transport occurs, okay? So here, not applications talk, here actually devices talk, or hosts, okay? So transport protocols actions in end systems: sender break application messages into segments, passes to network layer, right? Receiver assembles the segment into messages, passes to application layer. So this is how it works. Two transport protocols available to internet applications, TCP and UDP. This is important. So there's an analogy here to talk about what is the difference between transport versus network layer, right? Because here we are talking about the data is transferred between the network layers. There we will talk about IPs actually. So hosts have IPs, so IPs can talk. So question now arises, then why do we need the transport layer, right? So if we can, communicate from host to host. So idea is as follows. Here the analogy of house kids. So in the book, they briefly explain this. So idea is as follows. Assume that there are 12 kids in the house, and they all wrote a letter to somebody else, right? So think about network layer as follows, as the postal service. So it takes the letters from your house and sends it to another house, right? So this is the network layer. So think about this. You're communicating between IPs. So instead of IPs or hosts, we have houses. But in the house, there are more than one person. So when a letter is received at the house, actually then you have to distribute it to the kid that actually that letter is intended for. So you look at the letter and see whose that letter is sent for. So inside the house, you distribute it. So that part is actually the transport layer, okay? That is the analogy here. So processes are kids here. So at the transport layer, you gather the data from the processes and push it into the network layer. That is the idea, right? Yes, transport layer, communication between processes, relies on, enhances network layer services. Network layer, communication between hosts. But we haven't talked about network layer, but all you need to know, this is done by IPs. Every host has an IP, so the IPs communicate. And also important thing that it is still not a reliable protocol, okay? packets can get lost. All right. So also the info is as follows. So assume that here 12 kids wrote a letter. So you gathered them all together and give it to postal service, right? So gathering them is called multiplexing, because in the network layer you have only one postal service in this scenario, but you have letters from 12 different kids, right? So you combine them. So we talk about multiplexing and demultiplexing when we talk about internet protocols. There, a cable were used by more than one person, right? Here, demultiplexing is now for the, transport and network layers. So it's somewhat different, but the idea is the same. You gather all of the letters of the kids, give it to the network layer, and at the other end, other kids receive these letters, but they're still somebody has to distribute to all of these kids, and that is called demultiplexing. So here's the example with pictures. Transport layer actions. What you do is as follows. Sender actually is passed an application layer message. So here your application using a socket passes it to the transport layer. So you put the header values of the transport layer. So this is called now a segment. You pass it to the network layer. So you have to now you combine it with the IP. So at this part, the cables and, maybe communication channel might be wireless and so on, but it is sent from this IP address to this IP address. So you have physical and link layers that does this job, all right? So actually these layers don't care what happened in the previous layers, okay? They are just transferring it. So you receive the message, receiver receives segment from IP, checks header values, extract application layer message, and through the socket again, demultiplexing message up to application via socket. Yeah. So this part is called demultiplexing. So two principal internet transport protocols are UDP and TCP. TCP is short for Transmission Control Protocol. Reliable, in order delivery. So this is important. So this means that when you send this message or packets, you know that it will reach to the end, the receiver, and in order. So they are not received in different orders. There's a congestion control and flow control. This means that actually, if the person cannot receive your messages as fast as you want, here you actually start to send in a slower way. So people think that congestion control and flow control are identical. Actually, there's some small difference here. You're slowing it down maybe because the person cannot download it in a good way. But maybe since you are, sending it through these routers and so on, maybe routers are busy. So this way you can also slow things down. Okay, and TCP has this property. They can understand if the person can receive your messages in a fast way or slow way. So this way they can throttle themselves. Okay, we will briefly explain how this works. And yes, there's a connection setup. Before start transferring data, you actually have a three-way handshake, right? So this way you somehow authorize yourself, let's say, but actually there is no real authorization if you don't use cryptography at the end. Okay, UDP is different. UDP is short for User Datagram Protocol. Unreliable, unordered delivery, no frills extension of best effort IP. So as you can see, we said bad things here. So people always wonder then why do we use it? We will give an example to them. But more importantly, both of the protocols actually does not guarantee, does not have delay guarantees and bandwidth guarantees. And more importantly, they don't provide security. You don't have confidentiality here. So this is why we will talk about TLS and so on later on. Yes, this was the first part. We can move on to actually multiplexing and demultiplexing. So here idea is as follows. For instance, you are connecting to a server. So server has the Apache server and it sends a message. So your computer receives it. And this message is, you have many applications going on, like Skype. Again, here the headers. you receive it, and now the transport layer knows which application this message is intended for. Since this is HTTP message, transport layer sends this to your browser here, okay, not to Netflix or Skype. And also this also shows that the slides are old because people are using Zoom instead of Skype in 2023. But anyway, so question is, how did the transport layer know to deliver message to Firefox browser process rather than Netflix or the Skype process? That is the question. So this is how the multiplexing and demultiplexing is used for. So here, for instance, there are two applications, P1 and P2. So they use sockets, but they put their data to transport layer. So here the multiplexing occurs. Then the data is sent, and then these people receive the messages for the correct application. So multiplexing as sender, handle data from multiple sockets at transport header, later used for demultiplexing. Demultiplexing as the receiver, so you have again two applications. This time you receive data from this host and this host. There are different applications, P3 and P4, but they are intended for not the same application. One is intended for P1 and the other one is intended for P2. So here you do demultiplexing as receiver. So you use header info to deliver received segments to correct sockets. That is the whole idea. Okay. So how demultiplexing works? Host receives IP datagrams. Each datagram has source IP address, destination IP address. Each datagram carries one transport layer segment. Each segment has source destination port number. Host uses IP address and port number to direct segment to appropriate socket. So this is how things work. So in TCP and UDP segment format, you have the source port and destination port. But other than that, they have other fields. And for instance, in the TCP, you also have source IP and destination IP. And this will be the main difference between TCP and UDP. Oh, great. So you have the source port here, destination port here. And since this communication is bidirectional, when somebody receives a message like this, they also know the source port. So when they want to send a message to you, they will use this source port as their destination port. So that is the whole idea. So if you want to, create a datagram in the connectionless demultiplexing. So when you create a socket, you must specify host local port, okay, like this. When creating datagram to send into UDP socket, must specify destination IP, destination port number. When receiving host receives UDP segment, checks destination port number in segment, directs UDP segment to socket with that port number. IP UDP datagrams with same destination port number, but different source IP addresses and or source port numbers will be direct to the same socket at receiving host. So here's actually the part that's trying to show you the difference between TCP and UDP. In TCP, if you are receiving the data for your same port, but from different IP address, then they will be referred to different processes. In the UDP, they are sent to same process. Okay, so a connectionless demultiplexing example is as follows in this case. So this person is, using this socket 9157, and this one using is something different, 5775. And here you are listening at the socket 6428. Okay, so this application sends the packet as follows. Their source is this one, but their destination port is this one. Okay, a completely different. So when, of course, this sends, they just replace the source destination port. Right. This is what I explained in the previous slides. But if this computer also wants to send data to same port, this means that they will be received by the same application. Okay. In the TCP, these things are a little bit different. This is connection-oriented demultiplexing. So TCP socket identified by 4 tuples. In the UDP, you have 2 tuples, destination and source ports. Here, you have source IP, source port number, destination IP, destination port number. That is the main difference. At the demultiplexing part, receiver uses all 4 values to direct segment to appropriate sockets. Okay. Server may support many simultaneous TCP sockets, each socket identified by its own 4-tuple, each socket associated with a different connecting client. So here, as you can see, at the multiplexing example here, this process 4 is, creating a bidirectional communication with process 1 here. So they have their IP addresses, source and destination IP addresses and ports. Similarly, this P2 does the same thing. But here is that Apache server uses the port 80. This is because the first 1,000 ports actually reserved for popular things, right? 80 is for HTTP, 21 for FTP, and so on and so forth. So since everybody is connecting to the Apache server, their destination port is always 8. But now, since this is the TCP, these packets are not sent to the same process, but for every connecting application, Apache server creates another process. Okay. This is how everything works, although the ports are always 80. They are sent to here. Example shows that this same host creates another application. Okay, that application communicates with it with a different application here, although they are using the same port number. All right, destination port, but the receiving port are different. This is why Apache server regards them as two different processes. That is the good thing here. So the summary is multiplexing, demultiplexing based on segment datagram header field values. UDP, demultiplexing using destination port number only. TCP, demultiplexing using 4-tuple source and destination IP addresses and port numbers. Multiplexing, demultiplexing happen at all layers. We already mentioned this in Internet protocol. And this is actually how the processes talk. Then we will talk about UDP and TCP.